Hello friends, in this lecture we will uh, we will learn about the Bruhat decomposition, and it is the main and it is the very important concept in the linear algebra that we have a we have an special linear group of order 2, and we will see the decomposition of that special linear group of order 2 in some group. Okay, so let's start. So Bruhat decomposition. Okay, so we assume, so in this lecture we assume that our readers are familiar with the notions of the group actions, and now we will just briefly describe that what is the group action is, and what are the main properties of the group action. Okay, so start. So yeah, that's fine. So let G be a group. Let G be a group, and X be any set. X be any set. We say that G acts on X if there exists a map called that star from G cross G, G cross X to X, going that Gx going to G dot X, satisfying the following properties, that G star is star. So G star, so first property is identity star X is X for every X in X. To if we act a G2 on X and then we act G1, it is same as if we multiply G1 G2 in the group G and then acts on X. This holds for all G1 G2 in G and for all X in X. Okay, yeah. So example, the first example is we have the symmetric group G S3 Sn S3, and we take the set E 1 2 3, then define G star X is equal to G of X. Okay, and check that you can check that this G acts on set X. Okay. And the next example is let take G is equal to simple G L N R, G L N R, or generally G L N F, where F is field, F is in field, and the set X and the set X we take here we take the set X equal to our Fn, which is the n cross 1 column vectors. Then define M is a matrix in G star. Take a vector, let's say Vx, just let's M, just to take M into V. It is just a matrix multiplication, and check that G acts on X. So it is very easy to check that G acts on X. Okay. Similarly, take G is equal to SLNF, which is the set of all n cross n matrices with the entries in F, and so all those n cross n matrix with entries in F, such that determinant of M is 1. And similarly we take GS3, and then G acts on X by take M in this case and take V, but MV. Okay. So now we will give some important subset corresponding to the action. So just what is that? Take any, so let X in X. So suppose a group G acts on a set X. Let X in X. Now take the set Gx, which is all those G in G, such that G acting on X is equal to X. Okay. So this is a subset of G. In fact this is a subgroup. This is a a subgroup of G. You can check that. You can check that it is in fact a subgroup of G, and this Gx is called the stabilizer of X. It's called the stabilizer of X in G, and sometimes it is denoted as stabilizer of X, step X in G. Okay. And next, that for that action, suppose G acts on X, and for that action, so let X in X. Now we define a subset that G star X such that G in G, so it is a subset of X, okay, and it is called the orbit of X in G. Okay. Yeah. Okay. Now there is a very important theorem regarding the orbit and stabilizer. So the theorem is, that suppose a group G acts on a set X, then for X in X, G X, so it is the set of all left coset of Gx in G. So it is a notation. So it is a set of all the left cosets of Gx in G, and it is equivalent to the set orbit of X. Okay. So this set is in the bijective bijectively equivalent to this set. Okay. And the proof of this is easy. Just take the map phi from this set to orbit of X, just this set going to G times X, and check that phi is a bijective. Bijective map. Okay. Now in particular if order of G is finite and the cardinality of X is also finite, and G acts on X, then for X in X, even X in X, we have the cardinality of this set. Cardinality of this set is equal to the cardinality of this orbit of X. Okay, that is, so it is denoted as G. So index of Gx in G is equal to the is equal to the cardinality of orbit of x. Okay. Okay. Yeah. So okay. Yeah. So now we will now move to the main concept of this lecture, that is the Bruhat decomposition of the group Gl2f or Sl2f. Okay, so let me just add that Bruhat decomposition of Gl2f or Sl2f. Okay, so it is a very important concept. So yeah, so now take G here. Just take yeah, Gl2f, and the proof of Sl2f is similar. So take G as the Gl2f. So it is all those 2 by 2 matrices over the field F, such that determinant of M is non-zero. Okay, and we take X as F2, and we have seen that G acts on F2 by take any M and take any V, you just get the matrix multiplication. Okay, we just take the matrix multiplication. Yeah. Okay. Yeah. Now we take consider the standard basis vector E1, which is 1, 0. It is in F2, right? It is in F2, and the stabilizer of E1 in G. So what is the stabilizer of E1 in G? So the stabilizer of E1 in G, look at all those A, B, C, D, such that all those A, B, C, D in G, such that all those A, B, C, D in G, such that A, B, C, D, E1 is same as E1, right? Is same as E1. Okay, so what is that? So you can check that it is all those A, B, C, D in G, such that it is A and it is C is 1, 0. So it is nothing but all those 1. It is, so it is this set. Okay, so it is 1 B D, where BD is in F. Okay, yeah, yeah, okay. Now we take a subgroup B, which is nothing but all those upper triangular matrices, that is these matrices in GL to F, all those upper triangular matrices. Okay, so it is a subgroup of GL to F. So it is a subgroup of GL to F, which is equal to actually G here. G here. Okay, and consider an element W, which is this element. It is in G. Okay, in G. Okay, now we okay, yeah, so yeah, okay, so now yeah, so what is WE1? So the WE1 is it is of the form 0 0 is -1 and okay, this -1 is in F2, right? It's in F2, yeah. Now notice that what is BE1? So note that BE1 is equal to this star, it is 0, and this so BE1 is equal to, this is some non-zero element, this is non-zero element. Okay, so and it is spanned by this. So actually it is look like A0, where A is in F. Okay, so it's actually A0, A is in F, right? And what is BWE1? So BWE1, so if we multiply an element in this, so we get so here sorry, A is in F star, F is 10 here, AB, where A is in F and B is in F star, that is B should be on 0. Okay, and what is one, and then so clearly you can check that this F2, so this F2 is actually written as BE1 direct sum B BWE1, right? So take an element, here. If the so take an element in this in this set. If I take so if the first component of that element is non-zero, then it is in this set. And if the second component, and it is non-zero, so it is actually, you can write this is actually the disjoint union. So you can stand it for the disjoint union. So this and this, right? So actually what I will say is that, so we consider here the action of this group B, on the set F2, and we get the decomposition of F2 as the orbit, right? So BE1, it is the one orbit, and the other orbit is BWE1. So right, and it is the disjoint union, because if you take an element from F2, if the first component of F2 is non-zero, then it is in BE1, and if the second if the second component of F2 is non-zero, then it is in this set. Okay, and if you take any element which is in their intersection, so then the okay, so let me write. So let x comma y is in F2. Okay, so if y is 0, and if y is 0, then so then it is in and x is non-zero. Actually here x is actually x is F. So if y is 0, then clearly xy is in BE1. If y is non-zero, then xy is in BWE1. Okay, and if an element xy is in both BE1 intersection BWE1, this implies that y is non-zero because is here, and also y is 0 because is here. So which is a contradiction. So F2, we can write F2 in this way. Okay, and now we will use this decomposition of F2 to get a decomposition of our group G. Okay, so yeah, so now yeah, so our claim is that our G, which is equal to it is GL to F, it is actually B disjoint union B WB, so which is equal to actually B W B prime, where B prime is in B, right, is in B. So it's my claim. Okay, so now yeah, so take any element A, B, C, D, or which is equal to A is in this GL to F. Okay, it is in this yeah, GL to F. Now take now take AE1. So if A times, so now consider AE1. Okay, so AE1 is in F2, and we have F2 is equal to BE1 combination with B blue B, right, equation. So B E1 actually. So if AE1 is belongs to B1, this implies that AE1 is equal to some yes, actually it is we denote it by small g. It's fine, this is small g, small g is better notation, small g. So it is equal to GE1 is equal to B times E1. This implies that B inverse G E1 is equal to E1, right? And this implies that B inverse G belongs to the stabilizer of E1. So belongs to the stabilizer of E1, right? This is equal to G1. This is equal to the stabilizer of E1 in G, and observe that the stabilizer of E1 in G, it is actually containing in B, right? So B is the set of all upper triangular matrices, and the stabilizer of E1 in G. So it is also the upper triangular matrices with this condition that BD in F with D not equal to 0. Okay. So it's contained in B. So this implies that B inverse G, which is in the stabilizer of E1, which is contained in B, right? And B is in B. So therefore B is equal to G is equal to B. Okay. If GE1 if GE1 belongs to BWE1, if G belongs to BWE1, this implies that GE1 is equal to some G is equal to some B prime small WE1, where B prime is in B. This implies that B prime inverse W inverse G E1 is equal to E1, right? And this implies that B prime inverse belongs to the stabilizer of E1, which is contained in B, and this implies that B prime inverse these elements belongs to B. B actually, so it is actually G belongs to B. B prime, so it is in B and it is also B, so this implies that B belongs to B, B W B, okay, so so now if you take any G is in let's say B intersection B WB, then it is and then it is empty, because if you take G which is equal to some B1 equal to some B2 B3, right, where B1 B2 B3 belongs to B, and this implies that B1 B3 inverse B1 is equal to the B2 of W, okay, so B2 of W, and this implies that W equal to belongs to B, this implies W is equal to the form this element, right, from some this element but W equal to, you take here this, okay, so which is epsilon, okay, so therefore B intersection BWB is empty set, okay, so thus what is it, that GL2F, you can write this as B composition with BWB, so it is called the Bruhat decomposition of the group GL2F, okay, and similarly in the same way as so in the same way as above, we can write SL2F as B, some BWB, where the B we should take in this way, that so B, so it is SL2F, which is the form some 1 start 0 1, okay, so this subgroup, which is a subgroup of SL2F, okay, and all are same, okay, so it is the very important concept, and it is used in your future mathematics, okay, so fine, so yeah, okay.